So from here we have to start the stuff which we were working on in previous session. Today we will be talking about the data transmission protocols. What is the meaning of protocol? So protocols are basically the rules, the set of rules which we use for the particular purpose. Now data transmission protocol, that means the set of rules which are used for the transmission of the data. So simply we shall talk about it in the context of the Internet of Things, that is the IoT itself. And when we were like discussing the concepts related to the IoT, we talked about the sensors and the data acquisitions. So the details of the data transmission protocol we are going to talk about, and the common IoT communication protocols. First one is the MQTT, that is the message queuing telemetry transport. Okay. So this, I have talked about this previously also, but today we shall talk about it in very detailed manner, and we will be using it in our project also. So MQTT is simply a lightweight publish subscribe messaging protocol designed for low bandwidth, high latency, and unreliable network. Okay, low bandwidth, high latency, and unreliable network. So it's commonly used in the IoT applications where the devices need to send small amount of data with minimal overhead. So you have to understand this, that the message queuing telemetry transport, that is the MQTT, is simply for low bandwidth, high latency, unreliable networks. The use case could be that the MQTT is widely used in the smart home devices, wearable technology, and the remote monitoring system, where efficient communication is crucial. So in the smart home devices, basically there the bandwidth is not very high. So there the MQTT is used in the smart home devices. Then if we move further and talk about the next one, that is the COAP, that is the Constrained Application Protocol. So simply COAP is a protocol designed specifically for the constrained devices and networks in the IoT. And it works on the top of the UDP, that is the user datagram protocol. We shall also talk about the TCP/IP and the OSI reference model. Because when we talk about the network architecture, that time the OSI reference model and the TCP/IP protocols are very necessary. So UDP is a part of the TCP/IP protocol only. The UDP is the user datagram protocol, and it supports the request response communication similar to the HTTP. When we talk about the HTTP, that is the hypertext transfer protocol, which is used in the www, that is the World Wide Web. And that time when you are working on a website, when you search something on the Google, whatever websites you are fetching, they are having a protocol HTTP, that is the hypertext transfer protocol, which is in the websites. But the UDP is actually working internally. So simply the COAP is ideal for applications where power consumption and bandwidth are limited, such as the low power sensor networks and smart metering. Okay, metering, sorry. So simply these are the two major, you can say, protocols, although there are many more, but these are the two most popular. First one was the MQTT, and then the second one, which I discussed, that is the COAP. So COAP and the MQTT, we will be using the MQTT because most of the time when the small projects where we are not having a very big, industrial level things like equipments and all, that time we use that only. You can go definitely for that COAP also, COAP also. The next one is the HTTP itself. So when we talk about the hypertext transfer protocol, that is simply a widely used protocol on the internet for the transferring of the data. Although it's more resource incentive compared to the MQTT and the COAP. And HTTP is still used in the IoT for devices with better computational resources. Like in the www, when we talk about, that means like widely, worldwide, it is getting used. So whenever you are working like on a project and simply your data is on the cloud, so when you fetch it, you are on the website, that time you will be definitely having the HTTP working there. Okay, so simply the HTTP is still used in the IoT for devices with better computational resources or where integration with the web services is necessary. When you talk about the www, when you talk about the web services, you definitely require the HTTP. And let me quote it, that it's not HTTP only, actually it's the HTTPS, that is the Hypertext Transfer Protocol Secure. because these days the HTTP is not getting entertained. Simply we need the HTTPS. That is another part. But yes, simply HTTP is hypertext transfer protocol. The use cases could be like the HTTP is used in the IoT applications that need to interact directly with the web services or the cloud platforms. As I told you, when you are having your application or some project deployed and you are having your data which is getting stored in the cloud platform, so that time if you are sitting somewhere else, you are not on your laptop, you are just searching on your mobile or tablet or laptop, even wherever. You just want to log into your cloud platform and you are using the web services, definitely you will be using the HTTP. You can't deny it. You have to use it. You can't escape it. Then the next one is the LoRaWAN. That is simply the long range wide area network. LoRaWAN. That is the long range wide area network. So simply the LoRaWAN is long range, as the name implies. Low power wireless communication, low power wireless communication protocol. And it is especially designed for the IoT applications requiring long distance data transmission with minimal power consumption. Okay. And the use case could be that it is widely used in the applications like agriculture, asset tracking, and smart cities, where devices need to communicate over long distances, but low energy is used. So LoRaWAN is there. Then the next one is ZB. So ZB is a low power, low data rate wireless mesh network, and simply standard, like it is a networking standard often used in the home automation, industrial control, and the medical device communication. If I just come here on the web and I try to show you this ZB protocol, actually, it's ZigBee protocol. So you can see this image. This image you can see for the ZigBee. It's not so clear, but yes. So here you can see ZigBee controller is there in the pink, the ZigBee router FDD in the purple one. These all are the routers, and ZigBee end device, that is in the pink. End device is in the pinks, this baby pink color, and this one magenta is ZigBee control coordinator FFD. So the, like, yeah, this is the complete image you can see, and you should take the screenshot of it. So here, if we talk about the ZigBee, I already have told you the basic stuff related to that, and it is mainly for the personal area network. Okay, so simply here some components and types are given here. The ZigBee coordinator device, the ZigBee router, the ZigBee end device. ZigBee coordinator device, it communicates with routers, and this device is used for the connection of the devices, the connecting devices. And ZigBee router is used for passing the data. As the name implies, it is used for the passing of the data between the devices itself to route the data. And the end devices are going to be controlled simply with the help of this. You can see this. And these are some best characteristics description, general characteristics of ZigBee. Let's take this also. ZigBee. So here you can see the general characteristics. So simply the low power consumption, low data rate, that is 25 to 250 kbps. Short range it provides, that is 75 to 100 meters, 75 meters to 100 meters. And network join time is less than, you can say, or approximately 30 milliseconds join time. Support small and large network up to 65,000 devices theoretically, but practically only 250 devices. Okay, so practically only 240 devices. Low cost of products and cheap implementation, open source it is, and extremely low duty cycle, 3 frequency bandwidth with channels. Okay. So these are some characteristics, and along with that, the types. No. Operating frequency bands. So only one channel will be selected for the use in one time. 0, 1 to 10, 11 to 24. These are some ways for the channel across the world. 0 is for Europe, 1 to 10 is for the US and Australia, 11 to 24 is for like across the world. So the 0, which is Europe, it is 868 megahertz, and simply 1 to 10, that is 915 megahertz, and 11 to 26 is 2.4 gigahertz. Okay, so the next one after this is simply the importance of secure and efficient data transmission. So simply the security in the data transmission is required, and the critical need is that IoT devices often transmit sensitive data, including the personal, finance, or operational information. Ensuring secure data transmission. The secure data transmission is crucial to protect against the data breaches, okay, unauthorized access, and the cyber attacks. Then the importance simply the encryption actually in the security of the data transmission. The encryption is required for the security purposes, and the protocols like the MQTT and the COAP can be secured using the transport layer security. Now again, the TLS, that is the transport layer security, and the datagram transport layer security, DTLS, they come in the TCP, that is the transmission control protocol, TCP IP protocol suite, that is the transmission control protocol and the internet protocol suite. These all are coming from there only. Okay, all these layers of network are coming from that particular concept only, and I will definitely discuss it with you. Soon I will discuss it. As we shall complete this particular stuff, I will definitely move towards that. So to encrypt data, ensuring that it can be intercepted or tampered with during the transmission. Then the authentication and access control is also required in the security of the data transmission. So implementing a strong authentication mechanism and access control ensures that only authorized devices and users can access the data, further enhancing security. Because if there is no restriction of the usage, if there is no restriction and anybody can access, so definitely it will be harmful for the data. We have to secure it, so we have to put some restrictions onto it, that who is authorized to access the data or control the data or accessibility. Then efficiency in the data transmission is required for that bandwidth optimization. So IoT devices often operate on the network with limited bandwidth, and efficient data transmission protocols minimize the amount of the data sent. So when the efficiency is there in the transmission channels, so the bandwidth is optimized and the amount of the data which is sent over the network is reduced. Network congestion is reduced, and timely delivery of the information is done. That is the meaning of bandwidth optimization. Then in the efficiency in data transmission, you also have to understand about the low power consumption. So the efficient data transmission is crucial for IoT devices that are often battery powered. So protocols like MQTT and LoRaWAN, they are designed to minimize energy uses. So for the low power consumption, you can see the MQTT is the best one. It is available everywhere. Whatever important security and efficiency feature you are having, you will be getting an example here of MQTT. That means MQTT is best to use. That's why we will be also using the same. Then in the efficiency of the data transmission, latency reduction is also important to be understood. So in many IoT applications, such as the real-time monitoring and autonomous systems, low latency is critical. Efficient protocols ensuring that the data is transmitted with minimal delay, you can say, and enabling faster response times and better system performance. So that is the meaning of latency reduction. that data transmission should be with minimal delays, okay, and faster responses.